Hello and welcome to Chem Mastery with Dr. Z. In this video, I will be covering all the main points you need to master in order to get 9 in your Paper 2 AQA GCSE Chemistry exam. The Paper 2 will cover topics from 6 to 10 in your specification. Topic 6 is about the rate and extent of a chemical change. It starts off with the rate of the reaction graph. And this is important because it can come up in the exams quite frequently. And in this one, in these graphs, they usually give you either the amount of the product formed with the time or the change in the amount of reactant over time. What you need to know here is that the steeper the line of the graph, the faster the reaction. So as you can see here, as we go up, it's steeper. And if the question is about the reactants over time, then the graph will be the opposite. And then to make it steeper, then you need to draw one below the first one if it's of higher rate. And then they also can ask you to calculate the rate of the reaction at certain point or at certain time from the graph. In this case, you need to look at the time they're asking for. If it's this point of time, let's say it's 15 seconds, for example, and then you need to draw the tangent at this point for the graph, and then you will calculate the gradient of the tangent by calculating the change in y over the change in x. And that will give you the rate of the reaction at this particular point of time. The rate of the reaction and factors affecting the rate of the reaction is a common question in the exam. Well, you have to explain why certain variables can change the rate of the reaction. For any reaction to take place, you need the reactant to collide together and they need to have sufficient energy for that collision for the reaction to start. So these are the 5 factors that affect the rate of the reaction. So the first one is the temperature. So increasing temperature will increase the rate of the reaction. And this is because increasing temperature will increase the particles will start to move faster and the particle will collide with each other more frequently. Also, as the particles will gain energy, there will be more collisions with enough energy for the reaction to start. So increasing temperature will increase the rate of the reaction. Secondly is the pressure in case of gases or concentration in case of solution. In both cases, increasing pressure or concentrations means that we have more particles within the same volume. And if you have more particles, that means you're going to have more effective as well collisions between the particles. So the rate of the reaction will increase. Then increasing the surface area will also increase the rate of the reaction because if you increase the surface area where the surface area to volume ratio increases, that means that for the same volume of the solids, the particles will have more space or more area to work on, which means there will be more frequent collisions. So it's all due to increase in the number of collisions or more frequent collisions. So there is an increase in the rate of the reaction. And finally, the use of catalyst. The catalyst will increase the rate of the reaction by lowering the activation energy needed for the reaction to start. So with even though the same number of collision will take place, but more effective collisions will take place because more collisions will have enough activation energy for the reaction to start. So this is why a catalyst increases the rate of the reaction. And then we have reversible reactions and equilibrium. So for reversible reactions, we have the reactants which react to give the product. At the same time, the products will react in a reverse reaction to give you the reactant back. At equilibrium, the rate of the forward and reverse reactions will be exactly the same. So the ratio of the concentration of reactants and product will remain the same. It will not change. The equilibrium, however, at equilibrium, the equilibrium may lie at the right or the left, meaning at equilibrium, it doesn't mean the concentration of the reactant and product will be the same. but the concentration of the product could be higher than the reactant and vice versa, depending on that particular reaction. There are certain conditions that can affect where the equilibrium lie, and by controlling these conditions, we can actually increase the yield of the reaction because we can increase the amount or the concentration of the product according to Le Chatelier principle. So let's see what is Le Chatelier principle. Le Chatelier principle states that if a system is at equilibrium and a change is made to any of the conditions, then the system will respond to counteract that change. For example, if you have this reversible reaction, A plus B gives you C plus D. If you increase the concentration of one of the reactant, then the system is not at equilibrium anymore. That means the system will respond to counteract that by increasing the rate of the forward reaction. That means if you increase the concentration of the reactant, the yield or the concentration or the amount of product will also increase. So increasing concentration will not only increase the rate of the reaction, but it will also increase the yield of the product in case of the reversible reaction. And then the effect of pressure on changes on equilibrium. So if we change the pressure, increasing the pressure will favor the reaction to have a less number of moles of the um, um, less number of moles. So we will look at the reaction and see which one has less number of moles. In this reaction, for example, which is the Haber process, when nitrogen react with hydrogen to give ammonia, you can see there are 4 moles on the left-hand side for the reactant, and only 2 moles are produced as the product on the right-hand side. So if you increase the pressure, then the reaction will favor the formation of less number of moles, well, it will favor the formation of the product. We also know that increasing pressure will increase the rate of the reaction. So increasing pressure will increase the rate and will also in this type of reaction will increase the yield because it will favor the formation of the product or will favor the forward reaction. And finally, the effect of a temperature change in temperature on equilibrium. It will depend on whether the reaction is exothermic or endothermic. So for reversible reaction, if one direction is exothermic, the opposite direction or the reverse one is going to be endothermic. It doesn't have to be the forward one exothermic and the reverse one is endothermic, but this is just for an illustration or as an example. So if the forward reaction here is exothermic, that means that there is heat also here on the left hand on the right hand side for the product because this is exothermic. So in case of we increase the temperature of the reaction, then the reaction will react or the response of the reaction is try to counteract that increase in the heat. So it will push the reaction in the opposite side, meaning towards the endothermic to reduce the temperature. So in this case, in this type of reaction, if we increase the temperature, the yield will be reduced because the reaction will favor the endothermic one. So temperature here, increasing temperature will increase the rate, but will reduce the yield. And there must be some balance between the rate and the yield if we need a certain product in that particular reaction. Topic 7 is talking about organic chemistry, and we will cover the main points that you need in organic chemistry. So first of all, with the representation of organic molecule, the most important thing is the general formula for the hydrocarbons. So the general formula is a type of empirical formula that represent the composition of any member of the entire class of compounds. So for the hydrocarbons, you need to know the saturated hydrocarbons, which are the alkanes, which don't have any double bond at all. They have general formula CnH2n plus 2. So whatever the compound they're going to give you, they might give you the number of carbon atom and ask you to complete the number of hydrogens. So it's going to be CnH2n plus 2. So you double the number of carbon atoms and add 2. That will give you the number of hydrogen atoms. For the unsaturated hydrocarbons, which are the alkenes, these are the ones with the double bond. The general formula is CnH2n. So whatever the number of carbon atoms, you just need to double the number of hydrogens to get to the alkene as well. Physical properties of alkanes. Boiling point is a typical question in the exam. Well, you need to know that as a homologous series, there is a gradual change in the physical properties with the increase of the number of carbon atoms within the series. So here for alkanes, there is an increase in the boiling point with the increase of carbon atoms in the chain. And this is because there is an increase in the intermolecular forces between the molecules, so they will need more energy in order to boil. Viscosity is another physical properties, and increasing the number of carbon atom will also increase the viscosity. So the reason why viscosity increases is because of the increase in the size and increase in the intermolecular forces between the molecules. Then we need to learn about the complete combustion. The most important thing about complete combustion is to know that in presence of excess oxygen, the hydrocarbons will burn completely to give only two products, which are carbon dioxide and water. It's very common in your exam that they will give you a certain hydrocarbon and ask you to write a balanced equation for the complete combustion. In this case, they're not going to give you the product. You need to know exactly that this particular hydrocarbon will react with oxygen to give only carbon dioxide and water, and then you need to balance the equation. Incomplete combustion is in case we don't have enough oxygen or in the absence of enough oxygen, then the hydrocarbon will burn not only to give you carbon dioxide and water, but it will also give carbon monoxide and sometimes also will give you soot, which is the carbon particulate. We're going to talk about the problems of associated with incomplete combustion, which are the carbon monoxide and carbon or particulate in topic 9. The separation of the crude oil using fractional distillation into fractions. So crude oil is the main source of the hydrocarbon. It's a mixture of different hydrocarbon of different lengths. So we have so many different hydrocarbons, and in order to use these hydrocarbons, you need to separate them into fractions based on their boiling points. So it's a very common question in the exam where they ask you to explain this process. To explain the process, you need to mention the following. First of all, that the oil has to be heated into a furnace, and then the vapors will go into a fractionating column. Always refer to the temperature gradient within the fractionating column, where the temperature is higher at the bottom and it's lower at the top. And the different fraction will separate at different places within the column, where the ones with the lowest boiling points will be collected at the top, and the one with the highest boiling point will be collected down as we go down the fractionating column. At the bottom, the fractions which are solid, like asphalt, wax, paraffin, lubricating oil, can be collected. So whatever the hydrocarbons or the fraction they're going to give you, just look at the boiling point, refer to the temperature gradient within the fractionating column, and say that the different components with the different boiling points, where will they be collected from the column, the one with the lowest at the top, and then as you go down the higher temperature, the one with the higher boiling point will be collected. The most of the products that we get from fractional distillation of crude oils are the long chain hydrocarbons, which are less useful than the shorter chains ones. This is why cracking is important, which is the process of breaking down the longer chain hydrocarbons to give the shorter chain hydrocarbons, which are more useful. In cracking, they usually ask about the conditions needed, and there are two main conditions. The first one is heating or high temperature because you need to heat the hydrocarbons to vaporize them. And then you either use a catalyst, a hot catalyst, where the vaporized hydrocarbon are passed over a hot catalyst and like silica or alumina, and that is a type of catalytic cracking. The other type of cracking is the use of high temperature and use of steam. So you use steam, mix the vaporized hydrocarbon with the steam, um, and then use high temperature again, so that will initiate the thermal decomposition. This is called steam cracking. So you always need to mention the high temperature, and I either mention the use of steam or the use of the hot catalyst. The product of cracking are usually smaller chain hydrocarbons and also alkenes. When we talk about alkenes, the usual question about alkenes comes about the addition reactions of alkenes. Alkenes have double bond, as we know, and addition reaction, this double bond will break one of these two bonds and two other atoms or groups will be added. So you don't need to panic if they give you any questions with molecules that you're not used to or you haven't seen before. Just look at where is the double bond. So if we have a double bond like this one within any structure or within any molecule, then you, for example, ask you to add chlorine, or what you need to do is to break this double bond and add two atoms of chlorine into the two carbons. So this is going to be the product to chlorine, and then whatever the other they're gonna give you. Sometimes they will even give you cyclic structures, so you don't need to panic at all. Just look at where the double bond, remove the double bond, and instead add the two atoms. Also, there is the addition of water. In case of addition of water, if we add water to this alkene, then you end up with an alcohol. So you have an OH added to one carbon and the hydrogen added to the other carbon. So this is an alcohol. One of the main questions that come in the exam as well is how to test for the double bond. And we use bromine water to test for double bonds because bromine water is orange in color. And if you add few drops of bromine water to your sample, if there is a double bond, then it will turn colorless because bromine will be added to the double bond. So this is a way to distinguish the alkane from the alkenes. Ethanol is the main alcohol that you need to learn about or know about. Ethanol is manufactured either by the hydration or addition of water to alkenes, as we have seen by the addition reaction. This is a reversible reaction, or by the fermentation of glucose. So, in fermentation of glucose, you have glucose, and then you use an enzyme and yeast, and this enzyme will do fermentation and will produce carbon dioxide and ethanol. They usually ask about the optimum conditions for the fermentation. So because it's enzymatic reaction, so it must have an optimum temperature, and the optimum temperature for the enzymatic reaction is 25 to 45 degrees. Because if the temperature is too low, the yeast would be inactive. Or the enzyme would be inactive. If it's too high, the enzyme as a protein will be denatured. And then it should be under slightly acidic condition. And finally, this reaction must be under anaerobic condition or in the absence of air, because if there is air, there is oxygen, then the ethanol formed will be oxidized to give ethanoic acid. So we don't need the ethanoic acid, we need the ethanol. So this is why we need it under anaerobic conditions. As we said, oxidation of alcohols will give the corresponding carboxylic acid, which is another class of organic molecules. The usual question about carboxylic acid is the acidic properties of carboxylic acid. Carboxylic acids are acids. They have typical acidic properties. So these properties are that they dissolve in water to produce acidic solution which has pH less than 7. They react with metal carbonate to produce salt and carbon dioxide. So this is the carbon dioxide produced. And they react with more reactive metals like any acid to give salt and hydrogen. And finally, they react with bases to give salt and water. Finally, there are the polymers. So there are two types of polymers. There's the addition polymers and there's the condensation polymers. Addition polymers is the type of polymers that are formed of monomers, and these monomers are alkenes. So alkenes can be added together to give you the polymer which is called the polyalkenes. The alkene are the monomers and the alkenes are the polymer, and this is the repeating unit of polyethylene, for example. How to draw the structure of the polymer for addition polymer? So all what you need to do, you have n molecule of ethene that will react together to give you only one product. One molecule will be produced, or one product, which is the polyethylene or the polymer. So you only need to remove this double bond. So remove the double bond completely and only replace it with a single bond between the two carbons, and then add additional two single bonds on the sides of the two carbons that had the double bond. Draw the brackets and then n, which refers to that this is repeated n times, or we have n of these monomers or of these repeating units. Again, in your exam, they could give you any alkene with any substituents here. Doesn't have to be ethene, doesn't have to be hydrogens. So you just don't worry about that. You just need to put these substituents or these atoms in place and then just work on the double bond. So if you have something like propene, so it's going to be given to you as this. So in propene is CH3 here, hydrogen, and then the two hydrogen. This is propene. So again, to draw the polymer, just remove the double bond and replace this hydrogen in polyethylene with CH3. Draw the brackets and N. The condensation polymer is another type of polymers, but this comes from a reaction between two different molecules rather than one molecule. And the products will be two products, one main product, which is the polymer, and a small molecule, which is going to be water in case we react carboxylic acid with alcohol. So in condensation polymers, the carboxylic acids can react with polymers to give with alcohols to give you an ester bond, where the ester is the product of a reaction between alcohols and carboxylic acids to give you the ester. So in this reaction, the OH from the carboxylic acid group will react with the hydrogen from the alcohol. This is going to be removed as water molecule and will give you the ester group here that will link the different molecules together into polymer. For polymer formation, you will always find that the alcohol will have two hydroxyl groups and the carboxylic acid will have two carboxylic acid groups. This is why the different carboxylic acids will react with the different alcohols to give continuous carboxylic ester group and form the polymer. This is in addition to the water molecule as well. PET is one example of the polyester or the condensation polymers, where this is the carboxylic acid with the two carboxylic acid functional group, and this is the alcohol. So this is the 2OH. The water molecule will be removed in the condensation, and this is the repeating unit. In the repeating unit, make sure that you have one molecule from the carboxylic acid and one unit from the alcohol. And for the carboxylic acid, you end this with the C double bond O, remove the OH because this is the one that is going to be removed in the reaction. And for the alcohol on the other side, remove the hydrogen pen as well, because this is the one that's going to react with the OH from the carboxylic acid. And don't forget the small molecule, which is water. For naturally occurring polymers, you only need to know that proteins and DNA are naturally occurring polymers. For proteins, they come from the condensation of amino acids, which are molecules that have NH2 group or amino group and have carboxylic acid group. So a reaction between an amine and carboxylic acid with removal of water will give you the peptide bond. This is the bond that is formed and will give you the polypeptides. We call this polypeptides, and these are naturally occurring polymers. Also, the DNA, which is the deoxyribonucleic acid, which carries the genetic information. It has two polymer chains of monomers called nucleotides. So this is the most important information you need to know about the DNA as naturally occurring polymers that is formed of two polymer chains of monomers called nucleotide. Moving on to topic 8, which is the chemical analysis. The first thing you need to know is paper chromatography. This is a very common question in the exam. In paper chromatography, the things that usually come in the exams are related to how to perform paper chromatography. In paper chromatography, the most important points here is that when you put the starting line, or when you draw the starting line for paper chromatography, you need to use pencils and not a pen, because the pencil does not dissolve in the solvent, but the pen will dissolve in the solvent because it has dyes, and it can disturb the chromatography or the paper chromatography completely. In paper chromatography, you have the stationary phase and the mobile phase. The mobile phase is the solvent that you use, and different components in the mixture will have different solubility in the mobile phase. And also, the different component will have different interaction with the stationary phase, which is the paper in this case. So the different in the interaction and the solubility of the different component between these two phases will make the different components move at a different speed across the paper. This is why the different component will be separated, and we're going to see that there are different spots here corresponding to the different components. If you have a pure substance, it will only give you one spot. If the substance is not pure, if it's a mixture, then you're going to have different spots, each corresponding to one of the components. If the spot doesn't move at all and when you finish your column, when you finish your chromatography, that means that this particular component hasn't dissolved at all, or it doesn't dissolve in the solvent. Also, one of the very important points is that when you put your paper inside the beaker that has the solvent, you have to make sure that the level of the starting line is above the level of the solvent. And this is because if you put it below the solvent, the different component will dissolve in the solvent rather than going up the paper chromatography. In paper chromatography, you need to know how to calculate the RF value. To calculate the RF value in paper chromatography, you have the starting line, and also you have the solvent front, which is where the solvent has reached. So when you do paper chromatography, the solvent has to reach a certain level, and you need to mark this as your solvent front. So, and when you calculate the RF value for any spot, you need to calculate the distance that is traveled by the spot, calculated from the center of the spot and until the start line, and then divided by the distance moved by the solvent itself, calculated from the start point, which is a difference between the start point and the solvent front. Different solvents can lead to different RF values for the same component. So if you have the same component and use different solvent, you're going to have different RF value because they're going to have different solubility in different solvents. Testing for gases. So you need to, in the exam, they will usually ask you to test for a certain gas, for a certain metal, or for a certain anion. So starting off with gases, so the main gases are hydrogens. Hydrogen, when you use a burning splint held at the open end of a test tube, if it's hydrogen, it will create a squeaky pop sound. For oxygen, you use a glowing splint and insert it into the tube that has the oxygen. Then the splint will reignite or will relight again, which means this is oxygen. In case of carbon dioxide, you bubble the gas, if it's carbon dioxide, through lime water, which is a colorless solution. And if it's carbon dioxide, then you see that it will turn the lime water cloudy due to the formation of insoluble salt or insoluble solid. And then for chlorine, you use a damp litmus paper, and the chlorine will bleach the litmus paper. For cations or for metals, different cations can be tested. So first of all, the flame test. In flame test, you need to memorize the distinguished color of the flame when you use different metals or when we use different cations. So lithium in the flame test will give you crimson red flame. Sodium will give you yellow. Potassium will give you lilac. Calcium will be orange red, and copper is going to be green. You need to memorize these ones. We can also test for cations by the formation of insoluble solids or insoluble salts when some metals react with, or some cations react with sodium hydroxide. So some hydroxides are insoluble in water, and I will give you different solids or different precipitate. So calcium, aluminium, and magnesium, when they react with sodium hydroxide, they will give you white precipitate of the hydroxide. Aluminium can be even distinguished from the others because if you add excess of the sodium hydroxide, the solid that is formed will redissolve to give you a clear solution. Copper too can give you a blue precipitate with sodium hydroxide. Iron 2 will give you green precipitate, and iron 3 will give you brown precipitate. To test for anions, which are the negatively charged part of the molecules, we have carbonate. So to test for carbonate, we know that metal carbonates react with acid to give carbon dioxide. So to test for or detect the presence of carbonate, you can react them with dilute acid, like dilute hydrochloric acid, for example, and that will give you the carbon dioxide. Then you can test for the carbon dioxide using the lime water test. To test for halides, which are the chloride, bromide, and iodide, you will use the silver nitrate test. In silver nitrate test, you will add nitric acid first, and then you're going to add silver nitrate. If it gives you a white precipitate, then it's going to be chloride because silver chloride is white precipitate. If it gives you a cream precipitate, it's bromide, and if it's yellow precipitate, it's then silver iodide. And then finally, testing for sulfate. So sulfate can be tested for using barium chloride, because barium sulfate is insoluble white precipitate. So first you use dilute hydrochloric acid, you add that to your sample first, and then you add few drops of the barium chloride. If it's a sulfate salt there, then you're gonna see a white precipitate of barium sulfate. Finally, there is the instrumental test for metal ions. The only thing you need to know here is the name of the test. The name of the test is the flame emission spectroscopy, and usually they ask you to mention what is the instrumental method that you can use to test for metal ions. The advantage of this type of method is that it's accurate, sensitive, and rapid, which is more advantageous compared to the chemical tests. Topic 9, which is the chemistry of the atmosphere and global warming. First of all, they usually tend to ask you about the change in the composition of the air across the years, how the different the air composition changed. So billions of years ago, the air atmosphere started off with mainly carbon dioxide. And then, due to volcanic activity, nitrogen started to build up in the atmosphere. And then carbon dioxide started to decrease. And carbon dioxide decreased because carbon dioxide is a very soluble gas, and it dissolved in the water that was formed due to the condensation of water vapor, and it formed sedimentary rocks. And then later on, as algae started to form and plants, the carbon dioxide that was dissolved in water was taken up by the algae and plants. So carbon dioxide concentration decreased. And then later on, oxygen concentration started to increase, and the oxygen concentration increased due to the photosynthesis. So the photosynthesis gives you oxygen. Formation of crude oil, they can ask you to explain how crude oil were formed. Crude oil will form from the planktons or these algae and these plants used to live under the water millions of years ago. So when these plankton died, they were buried under a sedimentary rock, and then they were subjected to high temperature and pressure. So they changed into crude oil and gave natural gas as well. For coal, coal is different from crude oil because coal came from trees. So millions of years ago, the trees were buried under dirt and water. Um, Trees in swampy areas were buried under dirt and water, and then they were subjected again to high pressure and temperature, and then the wood in the trees was changed into coal. Greenhouse gases, how they are formed and their effect. So the greenhouse gases are water vapor, carbon dioxide, and methane. And the effect of the greenhouse gases, how does it affect and cause global warming? So the different electromagnetic radiation that comes from the sun will pass through the different layers of the Earth's atmosphere, and they will reach the air, they will reach the Earth, and these radiations will be absorbed, and that will help to maintain the temperature high enough to be suitable for living on the earth. Then part of this energy that was absorbed will be reflected back again, or will be radiated in the form of infrared radiation into space from earth. And then part of this will be absorbed by um, um, the greenhouse gases, which are the carbon dioxide and methane. And part of this will be reflected back again into Earth, and that will increase the temperature of the lower layers of the atmosphere and of Earth, and that will lead to global warming and melting of the ice caps and all of these problems related to global warming. So there are you should be familiar with the human activities that increases the greenhouse gases in the atmosphere. So any activity that increase the level of carbon dioxide or methane will increase the greenhouse gas effect and cause global warming. Like farming cattle will produce methane, burning rice will produce methane as well, burning fossil fuel will increase the level of carbon dioxide, decomposition of organic matter in landfill will give you methane, and of course, deforestation will increase the level of carbon dioxide because of reduced photosynthesis. Carbon footprint and its reduction. So the carbon footprint is the total amount of carbon dioxide or any other greenhouse gases emitted over the full life cycle of a product, service, or an event. So it can be reduced by reducing the activities that will increase the carbon dioxide emission, like using less fossil fuel, reducing the amount of travel and transportation, or by planting more trees. However, the actions that to be taken to reduce the carbon footprint might be limited because it's more difficult to do this. It would be much more expensive. Planting trees will take up land that is needed to plant crops or grow crops. Using solar panels, for example, using alternative sources, it might be very expensive, and it needs also very large spaces for the solar panels, in addition to the fact that it's unreliable source of energy. Then the atmospheric pollutants that come from fuel. So most fuel, including coal, will contain carbon, hydrogen, and also might contain some sulfur. So what are the main pollutants that come from burning fuel or using fuel? First of all, there is the carbon dioxide. That is one of the main pollutants. The problem of carbon dioxide is that it's one of the greenhouse gases and it causes global warming and climate change. And then we talked about the incomplete combustion and formation of carbon monoxide. Carbon monoxide is a toxic gas that causes suffocation because carbon monoxide would bind to the hemoglobin inside the red blood cells, preventing it from binding to the oxygen. So it's a toxic gas that causes suffocation. Also, incomplete combustion could produce carbon or particulate, and the problem with carbon is that it causes global dimming and respiratory problem. And then we have the sulfur. So we said that they contain some sulfur. So sulfur, by burning fuel, sulfur can react with oxygen from the air to give sulfur dioxide. Sulfur dioxide will then react with water in the rain and will be the cause of the acid rain. And the problem of acid rain is that it causes corrosion of building and statues. And then in car engines, when we burn fossil fuel or the petrol, there is a very high temperature produced where when nitrogen and oxygen from air can react together to give nitrogen oxides, and nitrogen oxides as well will accumulate in the air and they will dissolve in water from rain and cause acid rain, which causes the same problems here, corrosion of building and statues. Finally, the topic 10, which is using resources. I'm going to focus on the most important topics within this particular topic, which is the first of all is the HEPR process. So the HEPR process is the production of ammonia from nitrogen and hydrogen. The source of ammonia is air. The source of hydrogen is natural gases and hydrocarbons. This is a reversible reaction. The product here is ammonia, and then this is an exothermic reaction or exothermic process where heat is produced. The ammonia is used to make fertilizers, and then the optimum condition for the reaction are as follows: 450 degrees temperature, the pressure is 200 atmosphere, and we use ion catalyst. So the stages of the HEPR process, you need to know that nitrogen and hydrogen are mixed together first, and they are compressed using high pressure 200 atmosphere, and then the temperature is increased to 450 degrees. Then they pass through iron catalyst beads where they start to react together in this reversible reaction. So the products here, or what comes out here, is going to be the ammonia, which is the product, but also we're still going to have nitrogen and hydrogen because this is a reversible reaction. And then at the end, you need to separate the ammonia from the hydrogen and nitrogen. To do so, you need to cool the receiver tank here. When you cool it, only ammonia will be liquefied and can be collected here. The ammonia can be removed as a liquid, while hydrogen and nitrogen will remain as gases, and then they can be recycled back into the process. The how to balance the different conditions of the HEPR process to balance between the yield, rate of the reaction, and the cost. First of all, it's talking about the temperature. We said the temperature, optimum temperature is 450 degrees. So this is an exothermic reaction, and we said for exothermic reaction, if you increase the temperature, then the reaction will favor the reverse reaction, the endothermic 1. So that means by increasing the temperature, the yield will be reduced here. So we're going to get less of the ammonia. However, we need higher temperature in order to increase the rate of the reaction. So to balance between the rate and the yield, we chose a temperature of 450 degrees. And don't forget about the cost, because if you use very high temperature as well, that will increase the cost of the whole process. So to balance between these three, 450 degrees at the best. For the pressure increasing, this is for this reaction because there are less number of moles in the product here. So increasing the pressure will increase the yield, will favor the forward reaction. Also, increasing pressure will increase the rate of the reaction because of the increase in the collision between the reactant. So increasing pressure overall will increase both. However, we need to also look at the cost and safety. So if we use too high pressure, that means that will increase the cost of the process. And also there is a problem with the safety. So the optimum pressure here to balance between those is 200 atmosphere. And finally, the use of the catalyst. The catalyst is important here to increase the rate of the reaction, but it will not affect the yield because the catalyst will increase both reactions, the forward and the back and the reverse reaction. Since we talked about the Haber process, we must talk about fertilizers. So fertilizers will provide mineral ions needed for the healthy growth of plants. The most important type of fertilizers you need to know about is the NPK fertilizer, which is fertilizer that contains nitrogen, phosphorus, and potassium. So in here is nitrogen, P is the phosphorus, and K is the potassium. So any fertilizer compound that contain either nitrogen, phosphorus, or potassium will contain these, will be considered as the NPK fertilizers. So ammonium ion and nitrate ion will be source of the nitrogen, phosphate ion will be source of phosphorus, and then any potassium compound that is soluble will be source of potassium. And these are some examples where what are the essential elements in each of those. In your exam, they can give you different fertilizers and ask you which elements are there. And then we're mining raw material for fertilizers. So you need to know that phosphate rock cannot be used as fertilizers because they are not soluble, they are insoluble. So, but they are used to make fertilizers. So for the phosphate rock, you can react it with different acids, which will give you different product, and you need to know these products. So phosphate rock, when they react with nitric acid, they will give you two products, which are calcium nitrate and phosphoric acid. The phosphoric acid itself that is produced will be neutralized with ammonia to give ammonium phosphate. So these are the two product formed. And with sulfuric acid, that will give you single superphosphate, which is a mixture of calcium sulfate and calcium phosphate. With phosphoric acid, will give triple superphosphate, which is calcium phosphate. Making ammonium sulfate we need to make ammonium sulfate, which is used as a fertilizers. We make it industrially and we can make it in the lab. This is the flow chart of the process of making this ammonium sulfate industrially, where the air react with sulfur to give sulfur dioxide, and then this is react with water to give sulfuric acid. The ammonia is produced through the Haber process as we have described it, and then sulfuric acid react with the ammonia to give the ammonium sulfate. This reaction is a continuous process that produces a large scale of the ammonium sulfate. However, ammonium sulfate can be also made in the laboratory where you can measure a certain amount of a certain volume of ammonia, like 25 centimeter cubed, and then you're going to do like a normal titration with sulfuric acid, so you can know exactly where is the end point or where's the neutralization point, and then you can calculate exactly how much you need to use of the sulfuric acid with that much of the ammonia, and repeat this process without the use of the indicator and then you're gonna make the ammonium sulfate. You need to evaporate the water and get the ammonium sulfate in the lab. So in the exam, they can ask you to evaluate these two processes, and to do so, the main things you need to mention here is that the industrial process is a continuous process, and that the reactant are made from raw material like sulfur, air, and water, and also it can produce huge quantity and it's made quickly. This is on the other side, where in the laboratory method, it's not a continuous process, it's a batch process where you make small quantities every time. It's very slow process, and the reactant need to be purchased from a chemical supplier. Of course, you can also refer to the cost. Running a cost is different here. It's for the industrial method, it's an automated process, and that will reduce the labor and the cost, while the one in the lab is of higher cost. Another topic that sometimes comes in the exam is the life cycle assessment. So, life cycle assessment is a complete analysis of the impact of the manufactured product on the environment. And there are four main stages that you need to comment on for the life cycle assessment, which are the extraction and processing, the production, consumption, and disposal. In each of these, you need to refer to, when you do the life cycle assessment, you need to refer to the use of energy, the transport of material, and the release of waste into the environment. So this is an example of a question that came in the previous exam to evaluate the use of glass for milk bottles compared to with the use of polymers for milk bottles. Here you're gonna comment on the raw material. So the first stage, so for polymer, it's finite source or a non-renewable resource, which is crude oil, but for glass, it's limestone and sodium carbonate. And then don't forget to comment on the energy used to process the raw material. Here, it's much higher for the glass than for the polymer. Then moving on to the manufacture process itself. So the energy needed for the manufacture is higher for the glass than for polymer. And then you need to comment on the effect of the mass of the bottle. So the higher mass will mean higher transportation. It's going to be heavier, so more. You're going to use more energy for the transportation compared to the polymer. And then the third process, which is the usage. Remember that the mean number of times that you can use in the lifetime for glass is 25 times, but the polymer only once, which is better in terms of the glass. However, to reuse the glass, you need to wash it, which will use energy as well and use resources, which is water. And finally, the disposal, both of them can be recycled. And final comment, you can comment on the general use of the energy resources and the crude oil for the use of transportation and all of the other processes. Also, potable water is one of the topics that you need to know about. So, potable water is the water that is safe to drink. It's not pure water, and if a company refers to its water as pure, they don't need that. They don't mean that it's pure water. They mean it's potable water or it's safe to drink. So potable water comes either from fresh water or from salt water. The process of formation of potable water is different for um, starting off with the fresh water. So the fresh water has some insoluble particles and microbes. So they pass through sand filters where insoluble particles are removed. Then they go through the sterilization tank where they are sterilized using chlorine, ozone, or UV radiation to give you the potable water, which is safe to drink. In case of salt water, we use a process called desalination, which requires higher energy, which is remover of the salt. We can do this either using distillation. In distillation, it's going to be the same as the distillation you do in the lab, but it's going to be on larger tanks where a large quantity of the salt water is heated, use a lot of heat, and then the vapors will be condensed. Again, for cooling, you're going to need a lot of energy, and then it's going to be condensed and collected. The problem with that is the wastewater that remains after this is going to be too salty and it's not good for the ecosystem. The other process is the reverse osmosis. In reverse osmosis, you're going to have the seawater and you use a semi-permeable membranes, which are quite expensive. And then you apply high pressure where the semi-permeable membrane will only allow the water molecule to pass through, but not the salt molecules or the ions of the salt. So only water will pass. So you're going to have fresh water on the other side. Don't forget that at the end you also need to do the sterilization using ozone or or UV radiation. And then there is the wastewater treatment. Wastewater has a lot of wastes, like the nitrogenous waste that come from human or bacteria. It could be toxic coming from industry, and also it could contain pesticides and fertilizers if it comes from agriculture. So to treat the wastewater before the water is allowed back into the different water resources, first of all, the wastewater has to go through coarse filters. So this first step is the screening and grit removal, where these coarse filters will allow for the removal of the large particles. And then they go through a sedimentation tank where they are left for days. The small particles will precipitate or will form the sediment, and the water will be at the top, which is called the effluent. So the sediments, which is called the sewage sludge, is then digested anaerobically with bacteria, anaerobic digestion with specific bacteria, and that will give you some methane that can be used as a source of energy, and the remains can be used as fertilizers. The effluent, which is the top part, the liquid part, it can be treated with aerobic bacteria in this case to reduce the volume of the solid waste. And then if it has toxic material, then you need to add chemical to precipitate the metals. And then if you're going to use it as potable water, a source of potable water, then you need to sterilize it also using chlorine, ozone, or UV radiation at the end. When we talk about using materials and metals, you need to talk about corrosion, where a lot of metals are prone to corrosion. And corrosion comes from the oxidation of the metal. So when metals are subjected to air, they can react with oxygen and they can be oxidized. So the metal becomes weaker over time and it will eventually just change from being the metal into being the metal oxide. Rusting is a form of corrosion, but it needs a reaction of iron or steel with not only with oxygen but also with water. So rusting is a product of a reaction between iron, oxygen, water to give hydrated iron oxide. The hydrated iron oxide is orange-brown substance, which you normally see on the surface of rusty object. So it needs for rusting, we need both the oxygen and we also need the water. So in order to prevent rusting or prevent corrosion, especially rusting, you need to remove the substances that cause it rusting. So oxygen can be removed by storing the steel or by storing the material under unreactive nitrogen or argon, so remove the oxygen completely, or you could use a desiccant, which is a substance that will absorb water vapor, so remove all the water from the environment around your material. Also, you can use physical barriers to oxygen and water, like painting, oiling and greasing, or coating with plastic. There are several methods to prevent corrosion: electroplating, sacrificial protection, and galvanizing. So electroplating, when you have your metal, which is the iron, and you cover it with a layer of another metal, which is not reactive with air, like silver, for example. In this case, you use electrolysis. So you use the cathode from iron and the anode from silver, and then the electrolyte must contain the silver ion like silver nitrate, and then the silver will be reduced and it will coat the will coat the iron. There is also the sacrificial protection, where if you mix the iron with another metal which is more reactive, like zinc, then the zinc will be the one that will react with oxygen and water and will be oxidized rather than the iron itself. In this case, you're gonna end up with sacrificing the zinc in favor of the iron, so that will reduce the rusting. Galvanizing is a process of coating the iron with a layer of zinc. Well, the zinc itself will be oxidized, but the iron will not. So it's a protection of the iron. Finally, we will talk about polymers. So the polymers, there are different polymers which have different properties, and depending on the polymer and the process, how they will form. So for example, polyethylene, which are the polymers, which are some of the addition polymers we talked about. There are two types of these, which are the low density polymer and the high density polyethylene. So the difference between these is the difference in properties and uses. The low density one is flexible and reactive and can be made into films, so it's mostly used in carrier bags, while the high density one is strong and flexible and resistant to shattering, so it's used in plastic bottles, pipes, and buckets. The difference why they are low and high density and how they are different. The low density polyethylene, as we can see here at the top one, they have a structure where the polymer chain are branched, so that means the molecules are arranged randomly. This is why they have these properties. While the high density ones, they have less branching, or they are not branched, so they are more regularly arranged, or they lined up more closely. This is why they are hard and not soft like the low density polymers. Finally, there is the thermosoftening and thermosetting plastics. So plastics are another type of polymers, and there are two types of these depending on how they respond to heating. So the thermosoftening plastic will melt on heating, and the main reason for that is because the molecules or the layers of the polymers don't have a covalent bonding in between them, so that allows them to move over each other when they are heated, so they melt. But the thermosetting plastic, they don't melt when heated. They tend to char and burn upon heating because there is covalent bonding between the layers of the polymers. So that's the difference between these two. Finally, the alternative methods of extracting metals. So the Earth's resources of metals are limited. So we have copper ores are becoming more scarce, and they must use new methods to get copper from low-grade copper resources. And they use two methods. The first one is the phytomining, and the second one is the bioleaching. Phytomining, they use plants to absorb the copper from the land or from the ground, where this is a low-grade copper. Basically, the copper will accumulate or build up in the leaves of the plants. At the end, the plants can be incinerated or burned, and that will produce ash that contain the metal. Bioleaching is the use of bacteria to produce leachate solution that contain the soluble metal compounds. In both cases, you need to process this copper in order to obtain the pure copper. And you can do this by electrolysis or by using displacement reaction using scrap iron.